Okay, in this next question, we have an infinite geometric series. We can tell it's infinite because of the dot dot dot. And we got some lns in here, so it's not uncommon to have logs mixed in with geometric series. Alright, so consider the case whether that this is geometric. So if it's geometric, that means you're multiplying by the same amount each time, but it also means that if you divide by the same or successive terms, you always get the same amount. So that's how you set up an equation to solve for p. So we're going to take the second term divided by the first term equals the third term divided by the second term. Okay, and all the lns will cancel out. We just have p equals 1/3 over p. Simply multiply both sides by p, and we get p squared equals 1/3. So that means p equals positive, negative, don't forget the positive and negative square root, which equals, like in the question, positive, negative 1/√3. Part, we have to show whether it's convergent. So that's, look at the formula in the formula booklet. It's all about this little part here. It converges, in other words, the sum exists to infinity if the r value or the absolute value of the r value is less than 1. And in our case, the r value is, if you look at the series again, it's simply p. And so the absolute value of p is obviously 1/√3, whether it's positive or negative. The absolute value makes positive. That's definitely less than 1, so therefore the series is convergent. This is just 1 point on the mark scheme, and r 1 point, so you have to explain why it's convergent. In this next part, we are given that p is greater than 0, and we're given the sum to infinity, find the value of x. So we're given that p is greater than 0. Remember, p is equal to positive negative 1/√3. So this means p equals 1/√3, and we simply use this formula because we're given the sum to infinity. So we'll have sum to infinity, which is 3 plus √3 equals, u1 stands for the first term of the series, so that is ln x. Ln x, 1 minus the r value, which is simply p. So we have this, and we just simply solve for x. Let's multiply both sides of the equation by the denominator, and we have 3 plus √3, and 1 minus, I'm going to write this as √3/3, I think is a bit easier. Right, 1/√3, we can multiply the numerator and denominator by √3. So that equals √3/3. So let's expand these brackets. We get 3 minus √3 plus √3. And lastly, we got negative, it's going to be 3/3. These middle terms cancel, and we just got 3 minus 1, which is 2. 2 equals ln x. And the inverse of ln is e, so we have e squared equals x. Next, in part B, we're considering it to be an arithmetic series, okay, with a common difference of d. Show that p equals 2/3. So arithmetic means you subtract successive terms and you always get a constant. So we're going to take the second term, let's go all the way back here. Second term, subtract the first term, equals third term, subtract the second term. So it's p ln x. P ln x minus ln x has to be equal to 1/3 ln x minus p ln x. Okay, so then we have to show that p equals 2/3. So let's solve for p. Actually, again, we got ln x on every single term, so we can divide both sides by ln x, and we just have p minus 1 equals 1/3 minus p, and bring the p to the other side. We have 2p, and bring this 1 over here. We're going to have 4/3, right? 1 plus 1/3 is 4/3. Then we divide both sides by 2, which is like multiplying by half, and we got p equals 2/3. Okay, next in the second part of part B, we have write down d in the form k ln x, where k is a rational number. So write down command term means you don't have to show any work, you just write down the answer, so it should be pretty obvious. But D is just like right here. This is D and this is D. So D is P ln x minus ln x, and P is 2/3. So it's basically 2/3 ln x minus ln x is going to be negative 1/3 ln x. Okay, that's the value of D, which is in the form, k ln x, right? And lastly, we got the sum of the first n terms of the series is ln 1 over x cubed. Find the value of n. So let's talk about the sum of the first n terms. So we use the sum of the first n terms formula, and we can figure out what n is from this. So this is the sum. So we're going to start with the ln 1 over x cubed equals n is the thing we don't know. 2 times the first term in the sequence is ln x, and then we got n minus 1 times d, which is negative 1/3 ln x. Okay, so let's start solving this and figuring out what n is. Now, you remember in the previous examples, the lns all cancel, so I think something similar will happen here if we simplify with some log rules. So here we can simplify the left-hand side. This is ln 1 minus ln x cubed. And over here, I guess we're going to have to expand the brackets and stuff. Perhaps. But I'm not going to do it for now because I think the lns are all going to cancel just like before. Okay, so recall now ln 1 is 0. So we have ln in this term, ln in this term, and ln in the last term. We can do it like we did before. Well, actually, sorry, we need to rewrite this first as negative 3 ln x. And now we have a ln x. And then we have, I'm just going to rewrite this again. Don't want to expand yet, because now I can see we have just a log over here. So we can divide both sides by log x, and there's only 2 terms here, right? So you can cancel out these logs, and we'll have negative 3. Let's switch to blue. Negative 3 equals n over 2, and this is 2 plus n minus 1 times negative 1/3, so it's a lot easier to deal with, I think. So let's multiply both sides by 2. Get rid of these fractions. So we have negative 6 equals n, and this is 2 plus, or actually let's do minus. So we're going to have minus 1/3 n plus 1/3. Let's multiply both sides of the equation by 3. And then we get negative 8 equals n times 6 minus n plus 1. And then we have, n times 5 minus n. Looks like a quadratic, and we'll have to solve the quadratic by factorizing, I guess, since it's a non-calculator paper. Let's expand these brackets and bring the 18 to the other side. So we're going to have 5n minus n squared plus 18. Let's multiply by negative 1, and we got n squared minus 5n minus 18. Problem is, this shouldn't be a 5. Back here we have 6 plus 1 is 7, of course. So let's just change these all to 7. 7, 7. That's a 7. This makes sense. It's n minus 9, n plus 2. Remember, n is number of terms. It has to be a positive whole number. So we only get one answer. N equals 9.